Should be live now, right? I think so. Good. Okay, refresh. Let's see. So we're live now, right? Yeah, we're live. Okay. Alright, so let's continue. Last time we finished color triangles, so today we're going to start working on shaders. So when it comes to shaders, there are different kinds of shaders, but our main concern right now is, let's scroll back up. So I've not been live for 2 weeks. I've had other things to do the past 2 weeks, so they've kind of caused a lot of stress for me. And I haven't really felt like working on this for those 2 weeks, but now we're going to start modifying these shaders. So I already know that the shader language somewhat, so I'm just going to skip over this introduction here. So in our vertex shader, we can have a color that we want to return. Right here, so just to show you guys what we did last time, this is what we did last time. We did so we can change the viewport color and so on. So here we can have a color and a position. So basically we can set this vertex color variable if we want to. So this would be in the vertex shader. Out. We can just go \n. And that's it. Then there's the vertex color, which should be right here. This is a vertex color. Which is what I want the vertex color to be. So, yeah. Vertex color. There we go. That's the fragment shader. Let me just copy this. Should be over here. There we go. And then afterwards we can just go and take it. And then we can go set the frag color equal to a vertex color. And I don't know if it's going to compile, but it should change it to a red color, right? Yeah, now it's a red color. So in reality, we should be able to set the vertex color, if you remember. Oh yeah, we need to use a uniform for that. I think I wrote a function, right, for doing so that I can go over really quickly. It would be where we deal with VBOs, I think. No. The VBOs contains the vertices. It would be up in the fragment shader. Okay, I actually did not put it over here, but only the public set uniform. So anyways, instead of using this right here to set our colors, we can use a alternative. This will allow us to set it in code, but we don't want to do that. We prefer want to set it in our C code. So what we're going to do is that we're going to create a uniform, and we're going to set our frag color to a uniform. And after this, we can use this to set our color. So we can use get uniform location to get the location of a uniform. So in this case, we will just call the function in our program set uniform, and we would preferably want the whatever this takes in of arguments, a GL. This is helpful, but I'll just leave it empty for now. And this should be a void. Void. There's no real error message here, so yeah. But then afterwards, what we can go and do is cubic.cbp. We can go where we got all fragment shader. And then set uniform. And you go paste this code right here. We would want a the shader program, so we want all and then I think we have to go dot shader program, and this should be a const GL chop. Call it uniform name. It is a GL construct. It's meant to be a pointer or what? Maybe it's meant to be a pointer. Yeah, there we go. Pointer. Okay, good. And this is meant to be void. Void. There we go. This should allow us to set it now. So before we draw the shape, right, we can set the color. After we've used it, before we draw, we can go and set the color. So we're going to tell us what program we want to use. And then we can go shader set uniform. In reality, it doesn't really matter what we use, but I like to put it under fragment shader, if I remember. So I keep the cubic engine. I'll publish this eventually, but let me go back to my repos. We go bytes engine. Let's see now. Bytes.h. I do remember. I did not put it under fragment. Oh, I put it under shader program. Yeah, set shader color. I put it under the shader program. I guess that makes more sense. You preferably want it to be under there, so locally go. Shader program. Just to copy this. Go. And there should be an int. Oh yeah, it does have an error for if the location is invalid, so it should be int. And then for the this should be relocated. This should be the end location. Because the returns an integer, and then afterwards we can check if this location is valid, and then we can use this to set the actual thing. Oh yeah, actually we need the right. Yeah, and then we use that. So first we need the location. So fragment shader.set uniform would now be under shader. Program.set uniform. We'll figure out the parameters later. But after this, we get the uniform name and so on. If it's invalid, then we go. I wonder how we got the uniform here that we want to set. We use the shader program. That's important. That we're using the shader program. Look, in this case, it might not actually be important, but I don't know. We just probably want to be sure that nothing goes wrong. So we're going to be using shader program. And after this, we can go check if it's the correct location. Why do we need the fragment shader if we're just setting it? We need the shader program, right? But we already have the shader program, so it's unnecessary to get the shader program. But we still need the fragment shader that we want to use, right? We already got the shader program we want to use, so that's fine. Shader program. Shader program, and then go const shader. Does the fragment shader that we want to use. I assume this is the source code, right? Why are we printing out this? Shouldn't we be printing out location? Unable to get uniform location. Why are we printing out fragment shader? May cause unexpected behavior. Yeah, because it doesn't make sense to print the thing. Why would we want to print fragment shader? In this case, it's source. So yeah. Oh, look at this. Afterwards, we'll return 0 everything up correctly, and then I'll just copy this, paste it in here. Let's go on to pass for the fragment shader source. This is the vertex location. So after we get the location, we pass for the location right there. Yeah, and then afterwards we go call this. And in this case we don't actually have a color. But we need the uniform name if we want to set the uniform. Oh, the const has the name of the variable. Oh, okay, well in that case we can just leave it as being this. The name of the variable. Uniform name. And then afterwards we need the color that we want. So to color But in this case, it depends on if it's a vector 3 or 4, you know. Set uniform 4, we'll just call it set uniform 4. So you'll require a vector 4 to be passed through. Can we create a new, we got vector 2, we don't have vector 3, but we got vector 2 and we got color. So let's create a struct vector 3. Vector 3 float underscore x float underscore y float underscore set. And then we'll have a float x, float y, and float z. Then x will be equal to underscore x, equal to underscore y, and z will be equal to underscore z. There we go. And then I'll just go add that to the although in this case it's a color, so since we're dealing with that, it's a color. But the problem is colors can, I guess A would, so color, you know, since we're dealing with the fragment shader, which has uniforms, we want to do that. But yeah, so this should be instead it should be the and this is why it's important you get proper variable names. Like this, if I had, this is why I have proper names, because I would have no clue what this was referring to. But now at least I know what it's referring to. So yeah, anyways, so GL use shader program. That should be valid though. So it shouldn't be a problem. In this case, it's the unit. That they changed to be like red. Yeah, they did green, and this would be blue, and this would be alpha. There we go. Why this is frozen out is a good question. I have no idea. Is it because it's not valid with the let me just go add the first one, the vector 3 to the list, because we'll need that later. Oh, I see. It's because it thinks it's It's a class of structure for shouldn't be free hashtags because we're talking about the parameters. I feel like it should be free hashtags. Because now we're talking about the constructor, so it's free hashtags because we're talking about something that's part of the constructor. So free hashtags. So yeah, that makes sense. Free hashtags. We can literally just duplicate this fully. Put underscores in. And call it a day now. Well, so the next thing that we want to do. The fuck did this happen? What do you mean there's no live ones? Oh, there we go. It's here. Okay, great. It's here now. I don't know what happened, but yeah, okay, we're still live. Okay. So the next thing that we want to do is test it out, see if it works. So the way that we will do this, effectively, actually we should add more documentation. Let's see. Let's have more documentation. So what do we have? The shader program. Here we go. No, it's not called set shader color, it's called set uniform. And this is now called name and uniform color. And also it's a const GL chana. Let's just make it way short. The uniform that contain the uniform to tree. Volley off. Uniform color. This is the I assume you can use uniforms for other things, but they primarily used for colors, right? I mean, they're part of fragment sheet, as you know. So yeah, in that case, I would assume that they're used for colors. The color of the uniform. The color. Contain. And now we should just be able to, yeah, it will automatically change, by the way. But I don't like about this right now. It's cool and all, but you know what we can do? Also, I changed my mute button. It's now it's F6. It makes it so it does not compile whenever I have to mute for whatever reason. I was updating some stuff in Steam. Oh. Okay, this was Outlast, but we don't need it open right now, so let's just close it. So let's see if it works. Over here, we'll go. We don't need the fragment sheet, that's all we need to provide the name of it, which is going to be our color. And after that, we'll need to provide the color that we want to. So I assume you can just go color. How can you do this? Can you just do this or something? How was it that we did it down here? This works, right? This should work if I'm not wrong. Nope, it does not. No, don't search that. I know there is a way on how you can create structures. No. Struct declaration. A fucking spoon. It hit my eye, I think. Oh, this is valid, but can I do new? But isn't this like, no, you can't use new in this case. I guess alternatively we could just go color sp color goes to the equal to this, and then just go pass it through as being sp color. But this is valid. What? Oh fuck, I forgot that. C++, we need this to be copied over to there. That's fine. Alright. May have gone to back. Here we go. Done. Now that should be fixed. Good. Why is this still invalid? Is it an integer here? It is. Oh, it's called set uniform 4 now. That's fine. Okay, there we go. It's called set uniform 4. Let's run this. Yeah, okay, it it definitely did work. Oh, the alpha is 0. We should probably make it 1. What happens if we make it like 0 point? I'm just gonna do something random here. Try out something. Let's see what color we'll get. Alright, we got pink. That's fine. Alright, so as you can see, it works. I mean, I was expecting it to work, but yeah. So we can actually, instead of doing it that way, we can actually add it to our existing to our vertices if we wanted to, which is what we're going to do now because it's a lot easier. It also means that we can have them be multiple different colors if we wanted to. Let's just remove these comments. In reality, we don't need these indices really. I'm just gonna go copy and paste this in here. I'm just gonna remove these indices, so we don't really need them right now. And go back in our main. We don't actually need the indices right here, and we can just not specify any VO. This is valid. Well, yeah, it's because it has to be a vector. There. So here we have the colors, and here we have the positions. The way we do this is that instead of passing through 0 here, we'll pass through 7 now. Because now there's 7 in total, right? Yeah, 6, then we'll add another one for the transparency. Points from these. Stop, comma, stop. There we go. And that should be it. Here we'll need colors too. So we'll just go like, I don't know, 1.0, 1.0, 1.0. We'll just make it right. The second triangle will just be right. 1.0, 1.0. So the second triangle will just be right. There we go. So again, then I think what we can do is that we can make an offset. This we don't need anymore actually, but that's just one way that you can do it. So what we can do is that we can make an offset here now, and we can go and the way we would make an offset here is that we would go down into our shader code here. This is now going to be 7 as well, and 7, as we have 7 elements now. And here I believe we need to use, alright, we can do this first. This is our color now, so this is in the first location in this case. So yeah, this initializes the second one if I'm not wrong. Oh yeah, actually this one needs to stay free. The other one just has to stay 7. And then what we'll go up and do really quickly is that we'll go out and instead of having this a uniform here, we will have there'll be a second layout. Second layout. And what I think we can do, right, if I'm not wrong, we can go, yeah, all colors equal to a color. So we can get in all color instead of out. and then we can set all color here. Not there, but up here. And there you go. That's what we have done now. So this is a very basic example of how we can set a color, and now we just need to copy this. And yeah, we need to use void 3 times size of float. We still need to do that. But now what we can go down and do, let's just add a little space so you can see what is colors and what is not colors here. But what we now need to do is that once we have done the that we create these ones here. Now we need to do the same thing again, but this time I will duplicate them, and we will go 4, and we'll still go times 7, but this time we need to put an offset 1 1, and then go I think it's what, 3? Yeah, it's 3. 3 times the size of float. Yeah, there we go. And we just duplicate this for the second one as well. So we go copy and paste here basically for the second one. Uh, 3 times size of float. And that should be it now. So now what we can do is try to run it and see what will happen. It'll probably give us an error. Yeah. Oh yeah, that's because we tried to access all color. Why the fuck did we do that? We removed that, didn't we? Oh, by the way, this is invalid. Now we need to use draw arrays. We don't have any indices to draw, so. And count by the 7 now, because we have. How much do we have? I mean, isn't there a way that we could technically automate that? Where's the source code? Here we go. Source code. No, it's still just 3. We can just use 3 here. I don't know why I was set some other number, but there's only 3 parts that we need to draw, so yeah. Anyways, where do we access that variable though? That's a good question. I can't figure that out. Can we rebuild this? Alright, when error undefined variable or color. But it says, it has to be a vector 4, that's why. Also won't work. Actually, a color should be 4 as well. Else this won't work. We got a color, or color. Why it says that all color is undefined is a good question. Because this is the shader source right here, and they say in here. We go all colors equal to a color, and we take in all color, and we set all color equal to a color. That's really interesting. Hmm. Uh, let's try rebuilding. Nope. Alright, so all color is not defined. Doesn't make sense, but actually, is there any spelling mistakes? No. There's no spelling mistakes, so why doesn't this work? In all color and let's go look up some GL. Let's see. There might be some information about it. There we go. Um, this one is very interesting. I don't know. Why is all color not valid? We define it over here, and then we set it. Okay, not helpful. Why is all color not valid? Available color. mean, is this somewhere where we're trying to access it? It does not say that, though. It would have thrown an error if there was somewhere where we were trying to access it. Right. Yeah, then this would have been called, but it does not, so we're not trying to access it. I mean, it happens when we also compile it, so yeah. I mean, it looks right to me. Ow. Oh, wait a minute. Oh, ow. Oh, I forgot about this. We need to include this line right here as well. Also won't work. There we go. Now it should work fine. That was quite easy. And it won't load, so clearly we did something wrong. Oh wait, should this be 4? Because we have 4 to deal with. Is that why it's not working? No, but this is the offset, so this is how much we should offset it by, which is 3. And there's 4 in total once we have offset it, so yeah, right here, 4. I mean, I can go read up on what we used here. So let's see, vector 4, a color, vector. Oh, I know why. This has to be 4. No. There we go. We got a red one and we got a one over here. Now we can try to change the color of it. I would be interested in doing something like that. And luckily, that is quite straightforward. In reality, we could change these, but we could also have a variable that we can change. But that would require us to recompile the shader every time, which would be a very slow process to do. So just changing the uniform color seems easier. But yeah, that is another way that you can do it. Already written on shader class, so yeah, we don't really care about loading it from a file right now. So yeah. This is, I think, about, this is about reading from file, which we don't really care about. Alright, I was doing that. Textures. So next up, we're going to go over textures, which is why I got to last time. Textures are annoying, but they're not the worst thing in the world. Because we need to create our own texture maps and so on, which is kind of annoying, but yeah. As that'll be for next time, but now we're going to focus on setting it. So what I'll do is that I'll leave the second vector right here. We will have, I mean, I guess we could have 2 vertex shaders. I don't know how well that will go, but in theory, yeah, we could do that. And then we can just set normal color equal to then we'll need 2 fragment shaders. Yeah, it probably doesn't matter too much. And then we'll need 2 shader programs. There must be another way that we can do this without needing to create so many. I guess in theory you wouldn't really want to do it this way anyways, just due to the fact that you can't change it, so yeah, it would make more sense to just undo all of this and revert back to old way of doing it instead. I mean, yeah, Because I don't see why you would really want to do this anyways. So let's just see, we need an out for it, for that. Let's go look shitless. It's good at dealing with stuff like this. So here we go. Yeah, we need a out vertex color and the vertex shader and the fragment shader. We just need to get the vertex color. In this case, I'm just going to call it color, and this should be out. Color should be equal to, and here's where we need the uniform. Uniforms, here we go. Yeah, no, we actually need, we just need a uniform actually. We don't need to do anything up here. Which is nice, so we can just have a uniform. Uniform for color and set or fragment color equal to that. And then afterwards we can just set our color to whatever we want to. And that skips having to do all of this. So we can remove this. And we can remove this as well. The second thing that we want to do though is we of course need a color. We will call this object color. This does leave us with one issue though. How do we modify the colors of multiple objects? I guess the also we need to change this. There's only 3 now. The solution before would allow for multiple colors, but it would also require the recompiling of the entire vertex and fragment shader. And probably linking them together with the shader program again every time we modified the color, which would be very annoying. So it would not be a great solution. But for the time being, I'm not going to be too concerned about that. Let's just try to object color object color is equal to 0.0f no 1.0 yeah, just 0.0f 1.0f and then go. Then afterwards we'll go create a new ImGUI window dot free color viewport, not the viewport color, the yeah, we can have a static float as well, I guess. Here, call it stick down like here. Call it the object color and just pass for object color, and then go if this is true, we'll go color.red is equal to object color 0 And in theory, this should allow for us to change the color, right? So yeah, here we go. Why can't I go in and modify it? They're both called viewport color. Maybe I should change one of them to object color. Object color. That's a good question. It's 0 by 0, so yeah, you can do this. I knew it. Anyways, why is this not? Oh, it's because you use the same. Well, this one should be object color. Object. Search it over here. That's why. View color. View color. Oh, this already sets it. Oh yeah, that's right. There's nothing that actually sets them here. That's a bit of a problem. No, view color. But don't worry, we can fix that view color. View color. And that should be it. We can luckily change this just by going up here before we draw it, and we'll go object color, and then we will go Sheila program dot set uniform 4, and we will go to specify the color, and then we want to pass through object color. Yeah, there you go. You can see how it's changing now. Wow, this is really cool. So, I should be able to change the size with this, right? This is the GUI window, the position. So, and this is the size. So, let's make it like 2 by 2. Let's see, 2 by 2. Maybe like, I don't know, 100 by 100. That might give us a bit bigger of a window. Okay, maybe like for its x-axis be like 1,000. Oh no, 1,000 is too much. Be 200. 200 should be fine. Yeah, a bit more. Maybe 400. There we go. Now you can see everything. And there we go. Let's add like 50 of that and 100 here. And there you go. Very simple example. So next time I think I'll do some research on how we can have like multiple different objects with different colors without needing to create a bunch of shader programs. So yeah, I'll add that as like a to-do. that is what I'm going to do research about, and then we're going to figure out how to implement it next time. As for today, we're done, and we can move on to textures now. So I'll do that tomorrow. Then we will quickly append these changes. So yeah, we did get through something today at least. That also only took us about an hour. But let's see. I'll publish this game engine eventually if I get far with it. Commit. There we go. That's about the change that we made, right? Just add all changes. Code staged. This is the push, right? Yeah, push. Let's see. Refresh. There we go. 6. That's it for now, though. There's just the documentation right there. But yeah. I hope you guys enjoyed this video and this live stream, and I'll see you guys next time.